Hi, welcome to N6.2. This is all about factors and multiples. So the first thing you need to know is the difference between these two guys, factors and multiples. Let's start with multiples. Multiples are what you get when you multiply. Okay, so remember that M is what you get when you multiply. Okay, and I think Mrs. Uren has some examples coming up for us on the next slide. Factors are the little guys. They're the building blocks of any bigger number. So factors are the little dudes that you multiply together to get your multiple. For example, we can multiply 2 times 5, and that gives us 10. And so in this case, 2 and 5 are factors of 10. And 10 is a multiple of 2. Skip counting and multiples are related. If I'm going 2, 4, 6, 8, 10, I'm actually listing the multiples of 2. What would I get if I multiplied 2 by some stuff? Well, I would get all of these numbers. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So these are the multiples of 2. Listing two common multiples, well, if I listed multiples of 5, 10, 15, 20, you can see that my 2 and my 5 have somebody in common. It took a while to get there, but they do have some multiples in common. Not all numbers have multiples in common, but sometimes if you go, well, I guess technically they do if you multiply them by each other, but sometimes it takes a long time to find them. Prime and composite. Prime means they can't live in a factor tree. There are no other factors for it. So for example, let's take 11. If I were to try and make a factor tree for 11, I really can't, because 11 only has itself and 1 as factors, and you cannot put 1 in a factor tree. And so prime is any number that you can't build a factor tree for. So composite, you can build a tree. Look at my nice tree. So let's take a composite number like 30, and we can build a factor tree for that. We could say it's 2 times 15, and I always like to circle my primes. And to make a 15, we could say that's 5 times 3, and both of those are prime. They cannot be broken down anymore. They don't have factors other than 1 in themselves. Okay, so 30 is a composite number because we can make a tree out of it. 11 is prime. We cannot make a tree out of 11. Explaining why 0 and 1 are neither prime or composite. This is quite interesting stuff. 0 cannot go in a factor tree, because if you had a number like 30 and you tried to make a factor tree out of it, well, 0 can't live in there, because as soon as you multiply it by 0, you don't get 30 anymore, you get 0. So they, I don't know, math nerds way back in the day decided that 0 and 1 should be listed as neither prime or composite. Okay, same with 1. If we tried to put 1 in a factor tree, well, that just means we're going forever, because we're not getting anywhere, are we? Okay, so the number 1 and the number 0 can't be prime or composite. They just cannot live in the factor tree. I can tell if a number is prime or composite and explain why. So sometimes it's easy to make a factor tree, and sometimes it's easy to make kind of the factor loop. So let's do a factor loop for 36. Okay, I'm going to make a little T-chart here. So what makes 36? What are the factors, the little building blocks that I can put together to make a 36? Well, I can put 1 and 36 together, that's fine. What comes after 1? That's right, a 2. 2 times 18. What about a 3? 3 times 12. 4 times 9. Does 5 work? No, it does not. So we're not going to list it. But I did write it down there for you so you could see it just does not belong there because 5 is not a factor of 36. What about 6? Yes, 6 times itself. So if I went to 7 or to 8 or to 9, you realize that we've closed the loop. We're back, because 9 goes with 4 and so on and so on. So as soon as you can close the loop and close that gap, you are done and you have therefore listed all the factors of 36. Let's do another one real quick. Let's do 50. Okay, so 1 times 50, 2 times 25, 3 doesn't work, 4 doesn't work, 5 works, 5 times 10. Does 6, 7, 8, or 9 work? No, they do not. So that means you've closed the loop, and these are all the factors for 50. That's all he's got. Okay, so obviously 36 and 50 are composite numbers. Remember those two words, composite and prime. Listing all the factors, we just did that. That's exactly how you do that. Listing common factors, well, I can go through my list here and think what's common between 36 and 50. I only see 1. The 2 is the only number that's common. That's the only common factor that they have. Okay. Determine the prime factors of a whole number and explain the strategy used. My favorite way to list prime factors is with the factor tree, because if we took a number like 50, we can say that, well, that's 5 times 10, but this breaks down into 5 and 2. We circle all our primes, and then we can say that 50 is equal to 5 times 5 times 2. We can take all those little primies and connect them together, multiply them, and we've expressed 50 as a product of prime numbers. So there's the prime factors. I can solve problems involving factors, multiples, and prime factors.
The multiples of a number are like skip counting up from that number. So the multiples of 4 would start at 4, count up 4 more to 8, count 4 to 12, 16, 20, 24, 28, 32, 36, and so on. The multiples of 4 then are written in a list: 4, 8, 12, 16, 20, 24, 28, and 32. Multiples could go on forever, so usually teachers will ask you to list the first 10 multiples of a number. A sample question for multiples might ask you to list the multiples of a number. The first example shows 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Skip counting by 2. The multiples of 3 are going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. You can see by this list, 3 times 2 equals 6. 3 times 3 equals 9. 3 times 4 equals 12. 3 times 5 times 6, and so on. So the relationship between multiples and multiplying is shown. Another question you might get asked is, what is the lowest common multiple of each set, or the LCM? Common means in both lists. So I list my multiples, some multiples for 6, 12, 18, my color is jumping all over the place, 24, 30, 36. The multiples for 4, 8, 12, 16, 20, 24, 28, 32. Now, which numbers are common in both lists? You'll notice there's a 12 here and a 12 here, 24 here, 24 here. Those are the common multiples. The lowest common multiple would be 12. the numbers we multiply together to get another number. 2 of the factors of 6 are 2 and 3. Those aren't the only factors of 6 because 1 times 6 also equals 6. When you're listing the factors of a number, you want to list all of the factors. So let's try to see if we can find the factors of 12. One way is to make a list. Think of all the things that multiply together to give us 12. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. Then I can make a list. 1, 2, 3, 4, 6, and 12 are factors of 12. We can also make a rainbow. So I start with 1 times 12, and then I'm going to think 2 times 6, and 3 times 4. We'll call this a rainbow because the end times together equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. Another method is a factor tree. We can list 12 and then all the factors. 6 times 2, 12, 12 times 1, 12, 3 times 4. And we get the same list each time, whichever strategy we use. You may be asked to find the common factors of two numbers. First, you list all of the factors of the number. 1, 18, 2 times 9, 3 times 6. Then I'll list the factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Once I have my two lists, I can find the numbers that are common in both lists. Both lists have a 1, a 2, a 3, a 6. Those are the common factors of those two numbers. You may also be asked to find the greatest common factor, or GCF, of a number. The factors of 25 are 1, 5, and 25. Factors of 15, 1, 3, 5, and 15. The number that is common in both, ones are common and the 5s are common. The greatest common factor is 5 because it's the biggest number in both lists. Prime and composite numbers. Prime numbers have only 1 in themselves as factors. Nothing else will divide evenly into these numbers. Here's a list of all the prime numbers. Composite numbers are any numbers that have more than 2 factors. So any of the numbers that are not on the above list are composite numbers.